Welcome back to BrewFix, where coffee meets craftsmanship. If you've ever adjusted grind size, changed dose, tweaked pressure, or rewritten your recipe trying to lock in espresso quality, you've been chasing the same thing everyone does: control. But here's the uncomfortable truth. There is one espresso variable everyone tries to control, and no one actually can. Not baristas, not machines, not even laboratories. Today, we're breaking down what that variable is, why it refuses to obey, and how understanding this single limit changes how you approach espresso forever. The illusion of full control in espresso. Espresso culture encourages the idea that with the right recipe and enough precision, results become repeatable. We measure grams, seconds, bars, and degrees, and yet results still drift. According to espresso science, this isn't user error. It's because espresso is a system with internal variables that cannot be fully observed or controlled. The most important one lives inside the puck. The variable you can't control, water's path. The variable no one can truly control is the exact path water takes through the coffee puck. Once pressure is applied, water chooses routes based on microscopic differences in density, particle size, and resistance. These paths evolve during extraction as coffee swells, erodes, and redistributes fines. No machine, no technique, and no recipe can dictate this behavior precisely. Why puck prep can't solve it? Distribution tools, tamping techniques, and puck screens help reduce variability, but they don't eliminate it. Even perfectly prepared pucks contain micro voids and density gradients created during grinding. Under pressure, water exploits these weaknesses instantly. The science is clear. Puck prep narrows chaos, but cannot remove it. Why pressure and flow profiling still don't fix it? Modern machines allow pressure and flow profiling, but these controls operate at the system level, not the microscopic level. They influence how water enters the puck, not how it moves inside it. Flow profiling can slow damage, but it cannot force water to distribute evenly once resistance differences exist. Why this variable changes mid-shot? Even if water started flowing evenly, which it never does, extraction itself changes resistance over time. Fines migrate, pores collapse, and channels open. This means the variable everyone wants to control changes while the shot is happening. Espresso isn't just uncontrollable, it's dynamically uncontrollable. Why machines are designed around this limitation? Espresso machines don't attempt to control internal puck flow. Instead, they stabilize what can be controlled: temperature, pressure input, recovery time, and repeatability. From an engineering standpoint, this is acceptance, not failure. Machines are designed to manage the uncontrollable, not eliminate it. Why fighting this variable makes espresso worse? When people chase perfect control, they over-adjust. Small natural variations trigger unnecessary grind changes and recipe tweaks. This destabilizes the system and amplifies inconsistency. The science supports this. Excessive corrective input increases variability instead of reducing it. What professionals do instead? Professionals don't try to control water's path, they design around it. They use stable grinders, consistent puck prep, clean machines, and forgiving recipes. They accept small variation and focus on preventing catastrophic failure. This mindset produces better espresso more reliably than chasing precision. The most frustrating thing about espresso is also the most freeing. You don't control everything, and you never will. Once you understand which variable resists control, you stop fighting the process and start working with it. At BrewFix, we teach espresso the way it really behaves, not the way we wish it would. BrewFix, keeping your coffee machines running and your mornings caffeinated.